Sorry.
Okay, so here we go. I'm now officially recording, and we're going to share our screen and walk through how to use the conductivity probe, or really any Vernier probe that a teacher ends up borrowing can be used in the same format. So we've already gone ahead and downloaded Vernier graphical analysis, so it's on our computers, but otherwise you go to vernier.com, you go to downloads, eventually, and then you download graphical analysis 4. So once that's on our computers, then we can pull it up. And our probe is sitting over here. So we're now being offered sensor data collection. And so we hit data collect, and it's going to Bluetooth figure this out. And if it doesn't figure it out quickly, we're going to just double check and see that it's either on or off. If it's off, then we hit the on button. And now it finds it. So it's the Go Direct conductivity probe. If you are using a whole bunch, then you can find this code on the probe and you can find the exact one they're using. If every student in your class is using a different probe, then they can just make sure that they have connected their probe. So we'll hit connect. And then it is now officially connected. We'll hit done, and Vernier figures out what data we're looking to collect. So it's going to give us time and conductivity. And so now that this is on, we're going to go ahead and hit collect, and we can start it out. So you can see it is collecting data, and it's collecting data over 180 seconds, and it's collecting data up to 20,000. I don't know what that is.
Micro.
Yeah, micro somethings per centimeter. So we're going to toss it in the regular water and see what happens. And then if you want to see this a little bit better up close, you can click zoom to all data. And now we can see that it's reading out somewhere in the neighborhood of just above 500. So if we take it out, it goes back down to 0. And then if we stick it in sugar,
should you
sugar water solution, and it is less conductive than regular water. I have no idea what the pH of this water is, etc. It came out of the tap. So if we take it out of this, it'll go back down to 0. I'm going to put it in the regular water just to rinse it off. And then I'm going to stick it in salt. And once we stick in salt, we're like, oh, dang, salt is way more conductive.
All right.
And ideally, we're going to flatten off pretty quickly because there should be, a single readout. My suspicion is that if we swirl this water around, we're going to start getting some funky readings because it'll pick up more or fewer salt particles per volume. Let's see if that happens. It looks like, no, it's staying pretty similar. Either way, it's a very clear demonstration right now of how much more conductive the salt water is than the regular water or the sugar water. If we take this out and set it aside, we go back down to 0 and we hit stop data collection. So now you can highlight a section of this. And let's say we want to just see what happens with the regular water. We can go over here to the bottom left, graph tools, and we can apply a curve fit. We're pretty confident that this is linear, so we'll hit apply, and it gives us y equals mx plus b data to create our line. So you can just plug in your m and your b and get the equation of the line. If we do that again for salt, it's not a perfectly flat line, of course. The data that we collected we saw wasn't perfectly flat. If we go and apply a curve fit, we can do whatever we want. So if we want to apply a quadratic fit, we can. We're pretty confident that we're not looking at a quadratic fit or an inverse fit. We can. That's obviously not the line of best fit, so we'll go back to linear. And that looks pretty good. Ideally, what we'd like to see is something that was straight flat and had no slope whatsoever. If we wanted to do that, we could find just the end and say, okay, so we think that's our best data. Now let's apply our curve fit. It's linear. Still isn't perfect, but it's pretty close to no slope. And then we can get that data as well. Those are the basic tools. Down here, you've got a couple of other options. Ideally, this should be reading 0 right now because it's not in anything. And so if you want, you can go ahead and 0 it out. And I guess I probably should have done that right from the start, was 0 it out. And now it's giving us some negatives. So once it, once it settles itself down, the other option, of course, is you can stick it in the water and then you can 0 that so that your water is being called 0 conductivity or whatever you'd like it to be called. So we could hit 0, and now it would think of water as the baseline. So all of those are options that you can use if you like. You can now fiddle with this data. I think we can shift it around. We can change the scale. We can go up and down, etc. And there we go. I think that's it. Cool. I'm gonna stop and see. Kathy, do you have questions?
How do I print out this graph?
How do I print out this graph? Oh, that's a good question. That reminds me that I wanted to show you something else, and then we can answer that too. In view options, you can choose to view it as one graph, or sorry, where did the table go? Data table, there we go. You can pull up the data table so you can have them next to each other, or you can get rid of it and just have a data table. And if we scroll down, it's taking the data every second so we can see what's happening. You can give students just the data and have them graph it their darn selves if you want. You can give them just the data and have them create their own linear equations if you want. And then how do I print this is a great question. I haven't printed before, but I'm betting it's not terribly difficult. Let's see. I actually don't know the immediate answer to that. Okay. Whether it's up here somewhere, probably, oh, here we go, export. So we can export this data into a PNG file, or we can export it into, an Excel comma-separated value file if we want the data or the images. There we go.
Okay. Great. Well, cool. This sounds awesome. So much better than hooking up a multimeter and converting and doing. So this is awesome.
Yeah, it's a ton of fun too to play with. I mean, because you can do this really easily, and you can test other substances. You can, so super versatile. And this will work with all of our probes. If you're watching at home, all of our probes function in the same way. You would just connect whichever one you want, and it will bring you up the appropriate values in your data tables and graphs for whatever probe it sees is connected. And if you've got multiple probes set up at the same time, if you've got conductivity and salinity, you can change it to be 2 graphs, and then you'll have one of conductivity, one of salinity. So lots of fun options.
That sounds great. Well,
yeah.
I appreciate it, and it looks very simple, which makes me happy.
Cool. All right. I think that's it then. And let me know if you have questions. I'm going to get out of stop share, and I'm going to get out of record. Maybe. How do I get out of record?